So we are at chapter 7, and in this chapter we will talk about effective final and invoke dynamic. So in the last chapter we talked about the code evolution, how we do sorting with the JDK 1.3, 1.5, then 1.7 and 1.8. In this chapter we'll talk about this effective final and invoke dynamic. So first, let's do a simple code, and based on that let's understand this effective final. So we have an existing example which we already done for lambda. In the chapter 5 we have done this, and let's reuse the same example. So what I'm going to do is like I'm going to declare a instance variable called count, and this particular instance variable called count we gave a value 100. Inside lambda implementation we will be able to use all of your instance variable. Even we will be able to change those instance variable. There will not be any problem. So if you see, there is no compilation error here, everything is good. So all instance variables are shared by lambda expressions, and even you will be able to increment change the values of these instance variables. But what will happen to the local variable? So let's talk about the local variable now. So I'm going to declare a local variable called count1, and its value is going to be like 200. And inside our lambda expression, let's add this particular count1, and let me add it in the second lambda expression. So here we are going to define this particular, you are going to use those variable count1. Let's use it. So I have used count1, well and good, no problem using local variables, and we will be able to use it. But see what is going to happen if I am going to change this local variable, not even inside lambda but outside lambda. So this is outside lambda. Line number 14 is going to be like outside lambda. We are changing this particular instance variable. Okay. So when we are going to change this particular instance variable, the usage where we used the lambda, now we have a compilation error, and which tells that local variable count1 defined in an enclosing scope must be final or effectively final. So now the word effectively final, that's what we are trying to understand. We all know what is final. So if you declare a variable as final, its value cannot be changed. What is this effectively final? See, effectively final is a freedom given to the developer, in which what the system is telling, if you have a local variable, and as long as you do not use it inside lambda expression, well and good, you can change those variable values and all those things are fine. But if you try to use this local variable inside your lambda expression, then you should consider like maintaining it as a final variable. So you don't want to physically put final keyword, but maintain it as final variable. Physical we don't want to put it, but we need to maintain it as a final variable if we used it inside the lambda implementation. This is called final, effective final. See, effective final is a freedom given to developer, in which we don't want to define final keyword. Instead of that, we have to manage our underlying variable like a final variable. So that's what we have to do it. So this is not managed like a final variable. That's the reason why we got a compilation error, which states that local variable count1 defines in an enclosing scope must be final or effective final. Now if I'm going to comment this, things are fine and you will be able to use it. You cannot change it inside lambda also. If you try to do that, then you will again get the same compilation error as we saw before, right? So this is all about the effective final. So effective final, you need to maintain it like a final variable if you are going to use it inside your underlying lambda implementation. So the second one what we should know about is called invoke dynamic. So this particular invoke dynamic is a way how it's a bytecode instruction. So it is how the lambda expressions are invoked. So how the lambda expressions are invoked in Java 8. So inside the virtual machine instruction, if you see, there is something called invoke dynamic through which the lambda expressions are invoked. So what is this invoke dynamic? JDK 1.6 introduced this particular invoke dynamic to call functions from other languages. So from JDK 1.6, we can run other languages inside Java virtual machine. Say JavaScript functions you can call. So this Jython, Groovy, there are JVM languages. There are a lot of JVM languages, right? So we can call the functions of those languages from the virtual machine. So in the bytecode, they created something called invoke dynamic through which they do. The same functionality is used to call your lambda expression. So let's print this particular lambda variable and let's see. First, before printing it, let's call this and see. So I'm going to call the first lambda now, like get speed 100. Then we have a model called BMW. Okay. So now what happens? This 100 is going to come and sit in your speed, and BMW is going to come and sit in your model, and based on that, this particular implementation is going to get executed. And the response type, we will be getting the result. Now let's print this lambda variable object reference and let's see what's going to happen and what kind of output we are going to get. So let's write a quick main. So when you see the lambda variable, see how it printed. So this is not like a normal Java variable, and this is something like a inner class. Actually, it is not an inner class, and it is just like a proxy, right? So all lambda variables are proxies, and on this particular proxy only, we are calling our implementation, lambda implementation. So also remember that your lambda implementation, each and every lambda won't create a separate dot class file, whereas your inner classes will create a separate dot class file, and anonymous inner classes will get the name as your top level class $1 dot class. But here lambda expressions won't create a separate dot class file. All lambda variables are proxies, right? So they are all proxies, and there is a kind of architecture through which they are getting invoked. That's out of scope for our current session. Let's go deeper inside and let's see how the actual invocation is going to happen. There you will see the invoke dynamic bytecode instruction. So in order to look into the bytecode instructions, what we can do is like, let's go to command line and let's call a tool called Java P. So we have our source code here. Let's go to bin and let's set the class path until bin directory, and then percentage class path percentage. Now Java P, if you see Java P is having a command line argument called -c. -c will disassemble your code and it's going to release your show your bytecode instruction. Let's try doing this. Java P -c, and let's go here, pick up our package name and then our class name. Now this shows the bytecode instruction for our underlying .class file, and if you see here somewhere you will see this invoke dynamic two times. Instruction 24 and instruction 31 you see invoke dynamic, and that is where our two lambda expressions are getting called. How it is getting called? Your constructor invoke special, and there is another invoke special here which is going to call another set of instruction. Invoke interface is going to call your interface stuff. Invoke virtual is your system.out.println. So there are a lot of bytecode instructions like this, but invoke dynamic is the bytecode instruction which is used to invoke your lambda expression. They have re-engineered this invoke dynamic in order to invoke the lambda implementation. It took nearly 4 years to make this particular lambda execution to come to work faster, right? So that's the reason why JDK 7 and JDK 8, it took 7 years for the underlying organization, initially Sun Microsystem and then Oracle, to release Java 8. Right? This is all about the effective final and invoke dynamic. Thank you.